And here we go again. So we're halfway done. You're halfway done learning all the things that you can do with trig expressions. And it's a lot. So the plan is that we have lesson one and lesson two, and we're doing them over 3 days. So, take your some time with this and understand each part before moving on. Because I really believe that if we go slow with lesson one, lesson two is going to be a breeze because lesson two is nothing new. It's just all of this in a question with a goal. So, next video. The next video is that we're going to learn how to simplify by adding and subtracting. So we've learned how to simplify simply multiplying and simplifying fractions. We've learned how to simplify using our basic identities, so our reciprocal and our quotient identities. We've learned our Pythagorean identities, which pop up a lot. And then we've learned simplifying by factoring. Now, the fifth thing we're going to add on is simplifying by adding and subtracting. So we're going to be thinking about creating common denominators for terms. So when we look at a question like this, my first instinct is to look at this and be like, ooh, tan x. I want to change it to sine over cos. I also think of this as two terms and I look for a greatest common factor. All of those things are going on in my head. Now there is no greatest common factor, so I am going to change the cos x into sine x over cos x. So tan x will be sine x over cos x. Then I'm going to think of this as sine x over 1, so I'm going to multiply across. So I've got cos x plus sine squared x over cos x. And if this was the first lesson, I'd be like, well done, you're done. But we're learning how to simplify by adding and subtracting. So what will happen is that you'll always end up with 2 or 3 terms, generally just 2, where you have to add them. To add fractions, you need a common denominator. So this is cos x over 1, and this is sine squared x over cos x. So I'm going to create that common denominator of cos x by multiplying this fraction by cos x over cos x. That is going to leave me with cos squared x over cos x plus sine squared x over cos x. Now you don't need this step. You could jump straight to having that common denominator of cos x, and then my numerator would be cos squared x plus sine squared x, right? So common denominator, add your numerators. Hopefully some of you went, hey, look, it's a Pythagorean identity. Maybe. If not, here it is again. Two squared trig terms together trigger Pythagorean identities. So I go over here and I realize that sine squared x plus cos squared x equals 1, or cos squared x plus sine squared x equals 1. So I'm going to replace this with a 1 over cos x. That's a great answer. And in fact, that is the answer I would give. Potentially, the back of the book says secant x. I don't know. Both are great. Again, if this is on a test or when this is on a test, it will be multiple choice, and one of these two answers will be there. So if you get to 1 over cos x, change it to secant x. Then you'll be good. All right, next question. Next question, I've amped up the difficulty because I made it a binomial denominator. And I made it a binomial denominator with a further complication. We have cos theta minus sine theta, and then we have sine theta minus cos theta. Ooh dear. They're close, but they're not the same. Can I change the order? So you know how here we were talking about cos squared x plus sine squared x is the same as sine squared x plus cos squared x? These are not the same. If I changed the order, I would have negative, well, maybe I should write this down so you're not just listening, sine theta minus cos theta. If I change the order, it would be minus cos theta plus sine theta. Ugh, that's not the same as this, but it's close. You have two choices here. You can greatest common factor out a negative and then bring that negative up, or you could multiply by -1 over -1. This is kind of a new thing to me. A student started saying this and I was like, oh, that's actually kind of a nice way to do it. So I'm going to leave it up to you. In Math 50, we traditionally teach that if we want to change the order, we literally change the order and then we'd factor out a negative. So we'd have cos theta minus sine theta. And then that negative could come up to the top or kind of join in the middle. And then again, if you wanted to change the order, you could also just multiply by -1 over -1. The moral of the story is you will have 1 over cos theta minus sine theta minus, okay, what are we going to do here? Well, let's put a -1 on top, or some people just change this to a plus. And then I'm going to do is negative sine theta plus cos theta if I multiply that negative through. So I'm going to write it as cos theta minus sine theta. Now I have a common denominator of cos theta minus sine theta. And I'm going to simplify my numerator. I have 1 take away -1, which means it's 1 plus 1. So I have 2 over cos theta minus sine theta. Now that one was hard enough, so there's nothing more, right? There's no Pythagorean identities, there's no changing things into sines and cosines. That is just simplified. All right, last two in this group. So what do we do if we have binomial denominators that are just different? In other words, you can't multiply by -1 to change them, and they're just different. Well, the moral of the story, I gotta stop saying that. What you're going to do is create a common denominator. So if you have a 1 plus cos x and a 1 minus cos x, just make sure they're both there. So this one I'm going to multiply by 1 cos plus cos x over 1 plus cos x. And then this one I'm going to multiply by 1 minus cos x over 1 minus cos x. So I'm creating this common denominator of 1 minus cos x, 1 plus cos x. Now, different people show their work differently. I'm lazy. I hate writing my denominator twice when it's common. I like to do a big line and then look at what happens with the numerator. But sometimes that's just, well, you guys are math 60. We can do it. So our common denominator is 1 minus cos x, 1 plus cos x. Right? So instead of writing it twice, and then this numerator is going to be sine x times 1 minus cos x, and this numerator is going to be minus sine x times 1 plus cos x. The only reason I ever hesitate doing this is because I see so many people be like, oh, yay, done, done, done. I'm like, whoa, 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 what are you doing? You're not allowed to do that. So even though they're identical, you know, and it's in brackets and you're like, look, they're all the same, I can just get rid of them. You can't, because you have to do this subtraction before you can start doing any divisions. Right? So I have to simplify my numerator before I even think of simplifying. So I'm going to multiply through. So if that's a habit you're going to have, simplify as a fraction and as a fraction before you try to put them together. Okay, but we are going to have. Now I often don't multiply my denominator through until it becomes obvious that there's nothing else I can do. So I'm going to leave this as 1 minus cos x times 1 plus cos x. And then my numerator, I've got a sine x minus sine x times cos x. And then I'm multiplying a negative sine x through. So I've got negative sine x times 1. And then I've got negative sine x times cos x. Man, IT told me that if I muted it, that wouldn't show up, and it's still showing up. All right, now what? Well, I've got sine x minus sine x would be gone, and I have a negative sine x cos x and another negative sine x cos x. So I've got negative 2 sine x cos x all over. Now, here's where there's no way you would know to do this until you've done enough of these. If I left it as 1 minus cos x times 1 plus cos x and I looked at the back of the book, it wouldn't be there. I want you to start recognizing, and again, you're not going to know this right off the bat, only because I'm showing you. When I look at these two brackets, I look at them as conjugates, right? They're the same but with opposite signs. I know if I multiply them through, I'm going to end up with a difference of squares. In this difference of squares, I'm going to have 1 minus cos squared x, which in my head, I'm like, oof, Pythagorean identity. If you're not there yet, just keep going with me. So I'm going to multiply through. So I've got 1 times 1 is 1. And then I've got plus cos x minus cos x. So maybe you're at the place where you don't even have to write these down. Totally up to you. And then I've got negative cos squared x. So these middle terms will cancel out. I'm left with negative 2 sine x cos x all over 1 minus cos squared x, which I'm going to recognize as a Pythagorean identity. So I'm going to have negative 2 sine x cos x over, and again, you go to your formula sheet. I've got these memorized, so sometimes I forget, you don't. And some people will actually write the different iterations of these guys out. So like 1 minus cos squared x equals sine squared x. Feel free to, right? So this is going to be sine squared x. And now I can simplify. Sine x and the squared would leave me with 2 cos x over sine x. And again, these are big. I feel like our textbook really is trying to prepare you for some stuff coming up, and so they throw these ones in, but it's a lot. I mean, the answer to this one could even be negative 2 cotan x. Whew, right? Cos x over sine x is your quotient identity, which could be cotan x. So be kind to yourself. These are learning. And again, it's all lesson 1 and lesson 2. This is all we're doing for 3 days. So if this is feeling confusing, you got to just try things. You got to be like, oh, well, I got to this answer here and I thought this was great. But I looked at the back of the book and the answer was this. How the heck am I going to get there? We'll go back and look for, can I find any basic identities? Can I find any Pythagorean identities? Can I factor anything? All of these skills that you're learning are going to build up on each other. Last question. So for this one, I'm going to want to add these fractions, and I don't like having a tan, right? When I have a cos and a sine and then another tan, I'm like, oh, don't make this more complicated. So the first thing we're going to do is we're going to use our basic identities to replace tan x with sine x over cos x. Then we're going to create our common denominator. Our common denominator will be cos x times 1 plus sine x. So I'm going to multiply this one by 1 plus sine x over 1 plus sine x. And I'm going to multiply this guy by cos x over cos x. All right, what do I get? Well, I have a common denominator of cos x times 1 plus sine x. And then what do I have in my numerator? I have cos x times cos x, so I have a cos squared x, plus, now if you want to multiply through now, that's great, but I'm just going to write it as sine x times 1 plus sine x. Because I really want you to be tempted, right? I want you to think, oh, cos squared x divided by cos x is cos x. 1 plus sine x divided by 1 plus sine x is 1. Don't do it, right? There's a plus sign here. It's stopping you. You can't take part. You have to do the addition before you can start dividing. So instead, let's multiply through. So in my denominator, I've got cos x times 1 plus sine x. And then in my numerator, I've got cos squared x plus sine x plus sine squared x. I almost breathe. I breathe really hard when I'm like, oh, okay. Are they going to see this next thing? So what I need you to see is a Pythagorean identity. I'm just going to say that. Can you find it? Remember, you can change the order of things, right? This could be cos squared x plus sine squared x plus sine x. That's your Pythagorean identity. Cos squared x plus sine squared x is 1 plus sine x all over cos x times 1 plus sine x. Yay! Now I can go boom, boom, because there's no other addition that I have to do before I can divide. So now I can start dividing, right? When something divided by itself is 1, and then I am left with 1 over cos x, which is a great answer, or maybe it's secant x. Up to you, or I guess up to the textbook, or up to the answer key. So that is the next skill, which is simplifying by adding and subtracting fractions.